Hello class, welcome to our lesson in section 4.4. This deals with the graphs of secant and cosecant today. Similar to tangent and cotangent, our focus is going to be about how the graph is moving around, how translations are working, how is it affected by the period or amplitude changes. All of those things will be similar as we look at tangent and cotangent when we did that, and now looking at secant and cosecant. Remember that cosecant is the reciprocal of sine. So to graph cosecant, the easiest way is just to graph a sine function and then flip everything around. Wherever the graph hits equilibrium, there's going to be a vertical asymptote because if the answer was 0 for sine and you flip it, it's 1 over 0, which is undefined, which makes a vertical asymptote similar to what tangent and cotangent would have done. Any spot that's the highest and lowest point, which is the amplitude number, that's still going to be the same. It's just the graphs will make these parabola-looking shapes going up and down. So the best way is to make sure you figure out where those points are, so where the asymptote points and where the highest and lowest points are of the sine graph, and then flip it around to find cosecant. Similarly, when you find secant's graph, secant is the reciprocal of cosine. So you'll notice here that 0, 1, and pi over 2, 0, etc. These 5 points are the cosine graph, and you flip everything around. So any spot that's on equilibrium becomes an asymptote, and everything switches back and forth. Notice here on the y-axis, there's a point here above the equilibrium going upward, and then at pi going downward. Remember, this secant should be just slightly shifted over from cosecant. So if you look at cosecant again, notice they're just off by a pi over 2 situation, but they should look similar, just moved over, similar to sine and cosine. Everything else we're going to look at should be the same transformation ideas that we did in the past. So the 3 out front really doesn't do anything in terms of an actual amplitude, but does affect where the graph is. So think of it as if this is 3 cosine of x, the amplitude would be 3, so it starts up at 3, goes back to equilibrium, down 3, back, and up 3. Okay, that's the same idea here. It's just that there's no amplitude because these graphs go up and down forever. But you need the amplitude in order to find the answer, so you still have to know that part. And the period is 2 pi, so the 5 points I've drawn here would be the cosine graph, asymptotes on equilibrium, and then flip the graph around to figure out what 3 secant x looks like. Next one is cosecant of 1/2 x. I'm going to treat that similarly to sine of 1/2 x. So the graph should start, the graph should start at 0, 0 still, which is the case. The amplitude is none, but remember it's up 1, down 1 for those highest and lowest points of sine. And then the period should be 2 pi divided by 1/2, which is 4 pi, which means the graph is stretched out. So for this graph, I'm going to start at 0, 0. It should go up, back at 2 pi, and then we'll go down, back at 4 pi. On my graph paper, I'm out of space, so I'd have to work backwards in order to find that. You'll notice on your homework, you'll have to pay attention to the labels on the x and y axis in order to make sure that you have the right idea. Any spot that's on equilibrium or is a kind of an x-intercept would be an asymptote. Halfway between would be here at pi going upward, and then backward at negative pi would be going downward. Or similarly, if you went forward to 3 pi, it would also go downward. But notice, if I went from dot to dot and just drew a regular sine graph, that's what it would look like, and I just flip it around to make the cosecant graph. Next graph is secant of x plus pi over 4. Remember, that moves everything to the left pi over 4. When you're looking at application questions on homework, for example, that means it's a negative pi over 4 phase shift. You'll notice that these dots here just moved over. So these smaller dots would have been the regular cosine graph. I move all the spots over to the left, pi over 4. Any spot on the equilibrium is an asymptote, and all the highest and lowest spots are similar. You go up and down. Notice here I didn't draw this part to the left. It would keep going, though, and make a parabola, so don't think that the graph looks different than other cosecant and secant graphs. It still makes those parabolas up and down as you're looking at those situations. The next one has a lot going on. So there's a left pi over 2. The amplitude is none, but remember it's really up and down 2. There's an x-axis reflection, and I'm moving the graph up 1. Probably the most important thing to start with is moving the graph up 1, because now you just use that as your equilibrium. Okay, so that's your starting point. So the graph should start, since it's cosecant goes with sine, should start here, but it's to the left pi over 2, so that's why these locations are all moved over. So the smaller dots were the original location. I moved them all over pi over 2, so those are now the asymptotes. This spot at pi over 2 is now at pi, but notice it's down 2 from equilibrium, 1, 2, because it's an x-axis reflection and the amplitude number was 2. So I start down 2, draw the graph, and then go up 2, draw the other part of the graph for this section at pi. And what you want to focus on when you're looking at your questions is which graphs have the right period, which has the right starting point, where would the graph have started with originally, where does it move now. Those types of things will help eliminate answers to help you get on the right track. There's a lot going on this problem, though, to keep track of. So I would focus on a few things, maybe just the period and where the asymptotes are to start with, and then the other parts will kind of fall into place. Next question is just cosecant of x minus pi over 2, so that moves everything to the right pi over 2. Remember, this is similar to a sine graph. So the sine graph would have been just like this, these smaller dots here. I move them all to the right pi over 2. Okay, that would put this asymptote at pi over 2 and 3 pi over 2 now because I just shifted them over. And then this spot at pi over 2 moved over to pi, and that's the upward kind of parabola, and then similar for the downward parabola. Again, focus on the asymptotes. It was at 0, 0. I moved it over to the right, pi over 2, so that's where the asymptote needs to be. And I think that's a good strategy as you're looking at these questions. Next one, to the left, pi over 2. It's got a 1/2 and it's a negative, so it should be a sine graph, which means it should start here, but it has to move to the left pi over 2, so that's why the asymptote is at negative pi over 2. The next spot would have been at pi over 2, but it would be at negative 1/2 because the amplitude's 1/2 and it starts going downward. But I had to move it over, so that's why it ends up here at negative 1/2 on the y-axis, and then draw the parabola going down, similar parabola going up. Notice the period is 2 pi, negative pi over 2 to 0, and then adding in 3 pi over 2, that's really 2 pi from here to here. Okay, so you also want to focus on those ideas. Don't think it's from one asymptote to the other, though, in this case, because this graph takes 2 of those groups to repeat itself, because you need a downward and an upward, and then vice versa, and keep going and going and going, etc. So you got to make sure you go from one asymptote to the 3 asymptotes total to make one period of a secant or cosecant graph. I know a lot of these questions are kind of odd because we're used to sine and cosine. Remember, the focus for a lot of what we're going to do is the sine and cosine graphs. You're going to have to be able to deal with tangent and cotangent, secant and cosecant as you're going through your homework and to get ready for tests. But make sure you know sine and cosine really well. And actually, you got to know sine and cosine really well to be successful in secant and cosecant. Have a good day, everybody.